Hello everyone. Sarikap. Namaskar. Welcome you all to Rubber Industry News Hour. This is a weekly online program for the global rubber industry. Today we are on the episode number 48 of the Rubber Industry News Hour. In this episode, our focus is on the sustainable and cost-saving rubber re-engineering solutions from North Shore Rubber. We have two experts related to this topic, and they'll be giving a talk on this one. Also, we'll have a discussion on this. And Mr. Hugo Sandberg is Vice President Sales and Marketing for the North Shore Rubber USA, and Mr. Ted Nelson is Vice President of the Compounding Physical Testing Service, Akron Rubber Development Laboratory, ARDL. He's also a technical advisor for the North Shore Rubber. So we'll be discussing more about this topic later. In the beginning, let me introduce to you all about Technobase. Technobase is recognized as the International Resource Center for the Polymer and Process Technologies. We have two types of services. One is a professional education. We offer various educated services, online training, master classes, in-person programs. Also, we're also having diploma programs. And we do have publications and the digital library for the industry. Other than that, we have business services, exhibitions, conferences, virtual events, webinars, road shows, network events, factory audits, and also marketing and branding. Our main focus has always been the polymer industry. When it comes to polymer, we're talking about the rubber, plastics, polyurethanes, adhesives and coatings, and non-polymer side, we're on energy, environment, membranes and filtration, recycling and recovery, and also on the advanced side on the nanotechnology, smart manufacturing, and also some other chemical processes. You can always check our website technobase.org for more information on our activities and services. I do invite you all to join the journey of Technobase. You may find some of our activities useful to you, and feel free to reach out to me if you have any comments and suggestions or anything that we can assist you. Write an email to me, or you can reach out to me WhatsApp or telephone call. Let me quickly brief to you all about the services that we offer for the rubber, latex, and tire industries. One of the main activities of Technobase is the hosting in an exhibition, GRTE, Global Rubber, Latex, and Tire Expo. We're going to host within 2 months' time, 29 to 31st March 2023 in Bangkok. This is recognized as the gateway to global markets and a knowledge hub for the rubber, latex, and tire industries. You can check more details about it, expo.technobase.org. Please do participate. There are exhibiting, there are also visiting, there's a lot of educational talks also there at the GRTE. This is an in-person event. And we have another event, a Middle East Rubber and Tire Expo, which is the second edition of it, which will be going to be in Sharjah, United Arab Emirates, which is close to Dubai. We're hosting during the 21st to 22nd November. And again, we encourage you to participate. Please check the details at expo.technobase.org. At these exhibitions, we also focus on the research and development. So we invite all the researchers in the rubber industry to give presentations or publicize their work as posters. So research is one of the key components at our exhibitions. And also we offer lots of online training programs for the rubber industry through our know-how webinars project. We have more than 40 plus experts from the different parts of the world contributing very specialized subjects with the rubber industry. Currently, we have developed more than 250 short topics for the industry, which are 30 minutes to 3 hour long. And we also have more than 30 master classes, which are 1 day to 10 days long. And we are offering a 3 months diploma program this year in June. It is called Executive Diploma 360 Degrees Rubber Industry Technology and Management, and it is purely for the non-tire rubber industry, no latex, no tire, purely non-tire rubber industry. It covers both the technical as well as the management aspects of it. It is a 3-month online program, 4 hours a day. The batch starts in June. We also have publications. We publish our own books, rubber industry books. You can check our website store.technobase.org for the various books that we have published. We have more than 50 books. Some are pocket books, some are shorthand books as well. Okay, this is our every week's program, Rubber Industry News Hour, and this is focused on the rubber and tire industry. But we do have a latex industry focused program. This is a fortnightly. It means that once in 2 weeks. It's also free to subscribe to join for the latex industry professionals. And we do have a rubber industry connect program, which is basically a marketing and branding service, a digital marketing platform for the rubber technologies and also rubber industries. We offer memberships for this program and yearly membership. And if you're interested, you can reach out to me. Currently, we're working on the digital library for the rubber industry digital library. You can check at rubbery.technobis.org. Work in progress, hoping to be ready, utilize it in a month of April. And you can become the member. You can access many documents, brochures, technical sheets, all kinds of reports which are available for the public. And other than that, we have various consulting service. We offer the consulting, technical consulting, process audits, and also marketing and branding. And also we do the hosting of brainstorming sessions as well for the industry. Okay, that's about it. What is all about Technobis? Feel free to check our website, technobis.org. If you need any assistance, feel free to contact me. Okay, welcome you all to Rubber Industry News Server. Okay, we are on episode number 48. Today we have two experts from the rubber industry. They'll be giving a talk and have a discussion with them on the subject called the sustainable and cost-saving rubber reengineering solutions from North Shore Rubber. Let me introduce our speakers first. Mr. Hugo Sandberg he's Vice President Sales and Marketing for the North Shore Rubber. And he has been in the industry for the 28 years in the plastics, coating, and rubber industries, particularly with the companies like Rubbermaid, Little Tikes, Sherwin-Williams, the Flood Company, Excel Polymers, and Hexpol. He was involved in the marketing, product management, sales, and business development roles. And at Little, I have a brief story about him I want to read out, so please bear with me. At Little Tikes, Hugo managed the famous Koji Coupe, which was the world best-selling car. At Sherwin-Williams, he introduced Krylon Fusion, the first paint to stick to plastic. He holds a Bachelor of Arts degree from Bluffton University in Business and Accounting, as well as MBA from Duke University, Fuqua School of Business. Hugo entered the rubber industry by joining Excel Polymers in 2006. While at Excel, he was responsible for improving the performance of the transportation business unit as well as all branding activities before Excel was acquired by Hexpol in late 2010. With Hexpol, he moved into leading sales role. In 2014, he was asked to help lead the Robbins, a major player in molded rubber products for the retread industry. As a member of Robbins' team, he helped to transform the company with innovative improvements and a new culture. His last assignment for Hexpol was as a director of sales and marketing for Tire and Retread, where he managed all the OEM tire relationships in North America. After leaving Hexpol, Hugo joined the North Shore Rubber as Vice President Sales and Marketing. And North Shore Rubber operates as a leader in environmental and industrial sustainability, utilizing state-of-the-art recycling technology to provide high-quality recycled elastomers at competitive prices. The rubber devulcanization technology deployed by North Shore Rubber is award-winning, commercially scaled, and provides significant cost savings and carbon emission reductions without the use of chemicals or solvents. It will help North Shore Rubber to be the most attractive partner for customers in all the sectors of rubber industry. North Shore Rubber will be efficiently offering high quality materials and sustainable solutions while providing a platform for economic development and job creation in communities in which we operate. Now you can see his credentials to show you why he's talking about the subject sustainable and cost saving rubber engineering solutions from North Shore Rubber. Let me introduce our other expert, Mr. Ted Nelson. Currently is a Vice President of the Compounding and Physical Testing Service at Akron Rubber Development Laboratory. I was just talking to him. ARD is a legendary laboratory for the rubber industry, and he's working as a Vice President Compounding Physical Testing Service there. He's also providing consulting and technical advisor for the North Shore Rubber. About history of the experience of the Ted, he's been in the rubber industry for over 33 years. With a Bachelor of Science in Chemistry, he started his career in the rubber industry as a compound development chemist and process chemist with the Cooper Tire and Rubber Company. He then moved to the DS Brown Company to manage technical mixing and extrusion. From there, Ted did a stint in steel industry with Wallbridge Coatings, where he achieved his ASQ certification as a quality engineer. In 2002, he joined Hercules, the tire and rubber company in Findlay, Ohio, as the technical director, where he was responsible for the quality, technical service, product development, product quotations, and also sales for the custom mixing division. The plant was purchased by the Biltrite Industries in 2005, and then Robbins in 2009. Ted became a plant manager for the Robbins during the transition, was then promoted to Vice President of Technology over 3 facilities, and was transferred to the corporate office in Muscle Shoals in Alabama. In aftermath of the Hexful buyout of Robbins, Ted went to Airbus as a Director of Strategic Development in Ontario. Upon returning to Ohio in 2014, Ted joined Airedale's team of technical advisors, where he consults in all areas of polymer research, development, and testing. So you see, both Ted and Hugo got excellent experience, and it's a great opportunity for all of us to learn from them. And not only the subject, if you have any specific questions about various sustainable solution research related to rubber, here they are here. So it's a great opportunity. So let me invite both of them to come on board to give a presentation first, and then we have a discussion.
Morning, everybody. Hello, good day. We're excited to come and speak to you about North Shore Rubber and discuss a little bit more about a topic that has been very much in the news: sustainability in the rubber industry. As you all know, globally we have a lot of scrap tires that need to be worked away, and scrap tires have been the industry has done a pretty good job of making sure that scrap tires don't necessarily end up in landfills. But similarly, in the regular industry, non-tire rubber industry, we also have a scrap rubber problem, and the industry is still working on how to properly avoid those materials from going into landfills, or properly reutilize them, recycle them. The challenge that is in front of us is that when you look at scrap rubber, a lot of the scrap rubber ends up being used as a tire-derived fuel, as you can see on the little pyramid on the upper right-hand corner. Tire-derived fuel for cement kilns. Some of it goes into chrome production or micronizing. Those materials end up being utilized as a filler replacement at a fairly low percentage, which makes it a little bit more challenging to integrate those materials at a significant quantity. And at the top end of the pyramid is really the devulcanization of materials, and devulcanization has been an effort that has been tried ever since vulcanization of rubber came into existence. The challenge with devulcanization and all the previous technologies is that oftentimes it's a low percentage devulcanization, or uses chemicals or solvents, or has loss of material, or is simply not scalable or commercially viable. You may be able to do it, but you're spending way more money than you are for virgin material. And as a result, it's just very difficult to justify the technical resources required to integrate this material into virgin compound materials. What is rubber devulcanization? I'm going to hand the baton to Mr. Ted Nelson, who is our technical expert, who's going to explain that briefly.
Okay, so essentially what you're looking at is most rubber is cured with sulfur, and so you get some kind of sulfur bond that forms the cross links or the bridges from one polymer to another, one polymer chain to another chain. That gives the rubber that solid nature of it, and it also provides the wonderful properties that rubber has. So when you want to devulcanize, you actually want to preferentially break the sulfur bonds, sulfur carbon bonds, rather than the backbone of the polymer. Because when you break the backbone, essentially you're shortening the polymer chain, and you're going to reduce the capability of the rubber in anything you use it in after that. But with devulcanization, you break those cross links, and now you have, if you can devulcanize significantly, now you have a material that's essentially reusable. Much like when you melt plastics and can reform it, now you have something that you can remix into rubber compounds, and you can derive very good usable properties out of it by revulcanizing it with additional sulfur and accelerator. So that's essentially devulcanization.
Thank you, Ted. So the solution that that has been developed is our proprietary technology, and our proprietary technology, as a way of introduction, was developed up in Canada at the University of Waterloo by Professor Tsokanakis, and then was spun off into a separate company called Tyromer, and Tyromer is our technology partner up in Canada. North Shore Rubber is the exclusive licensee of the technology for the US and Mexico. Our technology results in material that can be used as a replacement of the polymer portion of the original formula. And that is important because all of the other previous technologies that have been in this space oftentimes ended up just being a filler replacement at the end of the day at a very low percentage. Our material can be introduced at a significantly high rate. High loading, we generally start our projects at 20%. Sometimes we have to back off a little bit, and oftentimes we can go significantly higher to the 45% range, and we have one customer who is using our material at 100% range, and just adds curatives to our material and is making products from that. The benefit of this material is that the customer is able to achieve significant environmental savings because they're able to get to zero waste stream. They're able to reduce their carbon footprint because the material is a significant less carbon emission versus original materials. And most importantly, we're able to achieve significant cost savings because the technology and the material that's resulting from it is significantly less than virgin material in the process. Our technology is what's unique about the technology and what Tyromer has developed is that this technology is already commercially proven. Millions of pounds have already been produced. Up in Canada, Cal Tire, who's a major tire OTR producer, has made over 10,000 tires, retread tires, utilizing this technology. It achieves a high percentage devulcanization. Ted, maybe you can chime in on the devulcanization aspect.
Yeah, I mean, when you measure, once you devulcanize, you measure using a swell method, and this material is shown to be well in the 90s, 94, 95 or above for actually breaking the crosslink. So devulcanizing, so you have opened up that much opportunity for reintegration and revulcanization of the product. So, and I guess I'll just finish this. This process used no chemicals whatsoever. It's a thermomechanical process. It's very high conversion output. You essentially lose pretty much nothing going through the process, and It uses a little bit of supercritical carbon dioxide to essentially aid the process in devulcanizing or in breaking the sulfur bonds. So it has pretty much very minimal impact on properties because, again, you're not breaking the backbone. You're just selectively breaking the cross links of sulfur. So, go on, you go.
Yep. And this technology has already achieved a number of innovation and sustainability awards and is produced in ISO 9001 certified facilities. And I should mention that there are multiple facilities that Terramer has set up both in Canada and in Europe with this technology, and will be the one with the technology in the U.S. What we offer is several different options for customers. We offer a tire-derived polymer, which can be used without sacrificing performance, and we offer two different versions. Our TDP-B is a 100% re-engineered master batch from truck and bus tires, and a TDP-C, which is a 100% re-engineered master batch from passenger tires. The difference being that while both of them have roughly the same overall polymer content, truck and bus tires have a higher percentage of natural rubber versus synthetic rubber, and passenger tires have silica introduced into the compound. So they each have different properties that might be interesting to different parties. The benefit here is that because there's plenty of feedstock, just in the US alone, 300 million tires a year, worldwide well over 1 billion tires a year, providing feedstock for this material. So that is our first offering. While obviously this type of material can easily go back into tires because that's where it's coming from, we've already done a number of case studies, including a presentation at the 2020 International Elastomer Conference, whereby we showed and proved that our material can be introduced into a number of other applications and polymer families. And Ted, maybe you can share a little bit more about that.
Yeah, I've been working with North Shore for about the last 5 years, and I've done a lot of work in the lab and then taken them to factory for them. And when you look at both the TDP-C and the TDP-B, both the tire, truck tire and the passenger tire, I've had very good success in not just the tread compounds for retreading, but conveyor belting is a very, very good use of this material because, again, it's got a lot of that SBR content. And we've been able to achieve properties that meet all of your RMA standards, your grade 2 conveyor belting. We've seen an equivalent heat aging properties. We've seen equivalent compression set properties, abrasion properties, tear properties. Some cases, tear actually increases. SBR molding, we've actually developed formulations that have been approved for use in OEM for vehicle manufacturing, meet and line callouts. And the interesting thing is we actually find that with a lot of the SBR derived materials that once you move it to the factory, you actually see a slight improvement in like tensile properties and some of the more mechanical properties. So I think the larger mixer actually may enhance the mixing. I've done some work with EPDM and chloroprene with these type of materials. Granted, I mean, EPDM and chloroprene have a certain compatibility with SBR and with natural rubber. It's not, you know, perfect compatibility, but I've been able to use between 10 and 20% material and maintain properties needed by, you know, the customers that are looking for those type of products. So there's a very broad range of capabilities here. It's a matter of sitting down and doing some work in the lab to compound it into it and not look at it as just a cheap filler or a low cost additive, but looking at it as an engineered material and how do you derive the best properties out of it. You go.
Thank you, Ted. The other option that our customers have is our closed loop management service. And what we can do there is, because a lot of our customers have significant scrap, and right now don't have a good outlet for utilizing that scrap, and oftentimes it goes into a landfill. What we can do is, through our partner network, is have that material picked up, have it brought back to our facility, have it processed and put through the devulcanization process, so that we can then offer it back to them or their designated custom mixer to reintegrate into their own formulations. The benefit there, of course, is that they know exactly what the material is, and can very finely define the integration rates and the processing, and it has a lot of customizable options for that. And of course, then you're eliminating a complete waste stream. You're also, again, reducing your raw material cost. You're enhancing your sustainability and your quality, and you're reducing your CO2 emissions. So it's a true closed loop system that works very, very well. So the competitive advantages of our material is that it can be integrated at high percentage integration rates. Like I mentioned earlier, 20 to 45% is very, very achievable. It's lower cost material than virgin material, and it has less price fluctuation, because the majority of our material has very little change in price. So we're really just subject to conversion cost changes, labor rates, etc., which are much more stable than just regular virgin materials. It meets all the applicable safety standards. It provides significant sustainability options for our customers, and the closed loop manufacturing management option gives you the ability to go to a zero waste stream and reduce your carbon footprint. So lots of benefits for our customers in making this part of your loop. So regarding carbon emission reduction, the tire compounds account for over 80% of the CO2 emission from raw material production of a tire. Utilizing the TDP to replace virgin rubber compound will provide more than 90% CO2 emission reduction. And as we move towards renewable energy and electric mobility, tire rubber compound production will be responsible for more than half of the life cycle CO2 emission of a tire. And so reducing CO2 emission from raw material production has never been more urgent. This statement is taken from a recent announcement, a co-announcement by Tyromer and Continental Tire, whereby Continental Tire announced a partnership with Tyromer and utilizing their technology. That happened in November of last year. Subsequent to that, Apollo Tire has also announced that they are adopting this technology. So we're having some major tire companies making public announcements about the adoption of this technology into their production processes and tires. So in summary, North Shore Rubber is a leader in environmental and industrial sustainability. We try to be cutting edge rubber devulcanization technology. We are committed to solving what has been a long time industry problem. People have been working on rubber devulcanization for as long as we have had vulcanization of rubber. Our mission is to be the most attractive partner in the industry by efficiently producing high quality material around sustainable solution. This helps resolve an enduring environmental crisis, integrates an award-winning technology to devulcanize rubber, enabling the widespread reuse of tires and scrap rubber, creates opportunity for closed loop manufacturing, generate cost savings for our customers. And while our initial facility will be based in Northeast Ohio, our plans include multiple facilities spread across the United States to be close to our customers. Our target industries really are anywhere rubber is used. There's no real restrictions on the material. Obviously, there's going to be some higher opportunities within that, but there's many different opportunities for this material and for this technology to be integrated into customer rubber. That is the end of our presentation. We invite you to engage with us. We'd love to talk about projects and how we can help your organization. You can reach us at info@northshorerubber.com, or check out our website, northshorerubber.com, or reach us at the number on the screen. And Param, that is the conclusion of our presentation, and we invite any questions from the audience.
Thank you, Hugo and Ted, for giving an informative presentation on the North Shore Rubber and also the product line and its benefits about it. We have quite a few questions before I show on the screen. In the meantime, maybe more information on North Shore Rubber background a little bit, and also the Ted, you can introduce about ARDL and the profile of ARDL activities at ARDL. Yeah, before we go for the Q&A session, guys. Please do post any questions you have in the question box, and both Hugo and Ted will address them appropriately in the discussion time now. So, Hugo, go first.
Yeah, so North Shore Rubber, we are a minority certified organization that was founded with our CEO is Wayne Embry Jr. We have been in existence for over 8 years. Based in the United States, but with definitely a global view, along with our technology partner, because we realize that a lot of customers that are potential targets for this technology have a global presence, with operations not just in the U.S. but also in Europe and Asia. And we feel strongly that with the background that the people in our organization bring, besides myself and Ted, we have a lot of rubber experience. We can really help customers in achieving this desired devulcanization and sustainability opportunity.
Okay, and to ARDL, we're an independent laboratory testing rubber and plastics testing laboratory. Been in existence for about 62 years. Owned by a family still. We offer testing about any kind of rubber testing to ASTM, ISO, EN, and specs all over the world. We are A2LA accredited to ISO 17025, international standard for independent testing laboratories. And we also have a fair amount of plastics testing. We also have an analytical group who can do failure analysis, so we including microscopy, SEM and TEM. We can do failure analysis, reverse engineering, pretty much anything like that, as well as some testing for chemical and chemotherapy against like rubber gloves and things like that to make sure there's no penetration. The thing that sets us apart from a lot of the independent testing laboratories is we have a engineering group who will design custom testing. We can test parts. We routinely work with customers. We've even built equipment just for one kind of test. We also have a technical group, and we do a lot of education, but we also do a lot of consulting, and that's like what I'm doing here is we work with customers or clients who need help with development of new compounds, new materials. A lot of times we get entrepreneurs who come in with an idea and they need prototypes. that will go from all the way from material selection, compound development, to molding the original prototypes and helping them improve or get the properties they're looking for. So, and then some of the technical advisors will also work with customers to help with improving their processes, their line production, problem solving, those kind of things. So we are a little different than a lot of the independent labs. We actually do everything from cradle to grave on the rubber industry, from basic rubber training to final part development and molding. So that's ARDL in a nutshell.
Thank you, Ted. Thank you, Hugo, for introducing more about North Shore Rubber as well as the ARDL. Guys, if you're interested in this presentation, you can download from the handout panel. On the panel, you find handout section. You can download that file, or if you're interested, get the contact. I think who has given you the email address, so you can reach out to him for further questions and inquiries. So now let's go to the Q&A session. We have quite a few questions here from the audience, and I would like to address them one by one. I will show on the screen. Okay, so the question, I do request you to, one of you to read the question, explain it, and also answer them appropriately. Yeah.
Okay, I'm not seeing it.
Are there any changes of mixing mechanism in Banbury with recycled rubber?
There can be. I always say the favorite answer to any question for a rubber technical person is it depends, and it's truly because it depends. There are some cases where you can mix exactly like you normally mix. You just add this in with the polymer and no issues. Other times where you can actually enhance the properties by changing the mix cycle, and there's some way we can help you with some of that. But the only thing we found that we've routinely shown is that you really don't want to get the master batch if you're mixing the TDP or the CMS. If you're mixing in the master batch where you tend to get a much higher temperature, you don't really want to go above 280 degrees Fahrenheit. Now, that doesn't mean you can't and it won't work. It's just that we find that the properties are optimal when you stay at a 280 degree drop temperature. Other than that, we really haven't seen anything that's universal. Everything else, I mean, we have formulas where you can mix in the master batch. We have formulas where you mix in the final pass, and it just depends on the compound, what you're trying to achieve, what the content is that you're putting in. Thank you.
Ted, you can see the screen by clicking on the blue flower and the icon at the bottom on the desktop.
I saw this. Is there another question?
Yes, please.
I think we're ready for the next question. The question is, how is market growth for North Shore Rubber, and are you limited to North America? The amount of interest that we're seeing from customers for our services has definitely been growing very significantly, and we expect that with the recent announcements by the major tire companies, that will only continue to accelerate. As far as limited to North America, We work very closely with our technology partner, Tyromer. So while North Shore Rubber itself is operating in North America, we work on a global basis through our technology partner, Tyromer. So we can definitely help engage customers in projects wherever they are, and do it in a partnership fashion. So as far as any comments on the handling of TDP and TDPB and TDPC and storage, Ted, do you want to comment on that?
Yeah. Really what we found is we recommend a shelf life of 1 year or less. If it's stored in a standard laboratory or warehouse conditions, what you will see is a slight increase in the viscosity over time. It usually increases over about 6 months and then levels off. Again, this is TDPB and C. Not much different than a lot of polymers that will sit in a warehouse that will just slowly stiffen up a little bit. In general, though, once you put it in the mixer, it goes right back down and mixes without any real issue. But the idea is to keep, just like everything else, you want to package it properly. You want to keep it stored in a warehouse that really doesn't give much above 80, 85 degrees or 30 degrees C. And you want to keep it covered.
How is the perception of non-tire rubber product manufacturers towards recycling and carbon footprint reduction? So I would say that in general, everybody in the rubber industry is looking to find ways to be more integrated, to reduce their scrap, and to reduce their carbon footprint reduction. Of course, with the prevalence of tire manufacturers in the rubber industry, that is probably a larger focus. But I would say that most of the other participants in the rubber industry are similarly interested in at different levels, and some of that is predicated by what their end customers are requiring, or their government entity customers are requiring. And in many cases, people are simply preparing themselves for coming regulatory changes to that's going to require them to be able to have more recycled content in their compounds. And you know, when the prevalence of people looking at alternative carbon black materials or process oil materials, this is in that similar vein. And Ted, maybe you can comment further on that, because I know you're working with customers in that realm.
Yeah, I mean, it's like anything else. Everybody's cautious, but they want to do what's best. So they're working with different materials. In some cases, we have manufacturers that are working with multiple and trying to stack the technology together to achieve a higher percent of recycled content. So it's kind of one of those things. Every application isn't the best for any one thing. So you got to kind of look at all the opportunities. And I think manufacturers in general are looking for the opportunities that best fit them. And although this technology is relatively new compared to the other technologies, so they're just really, some of the smaller guys are just starting to really get into this, but it's actually showing a lot faster inclusion than some of the previous stuff that I've worked with.
Can you tell us some more about some of the material applications where TDP material has worked well? Ted?
Again, I mean, it's the places where it's worked very well is obviously treads, but conveyor belt manufacturing, the conveyor belt compounds, it's worked quite well. We've also seen, like I said, we've also had some success where we've had approvals in some automotive parts. So it's more for a much easier fit where it fits into a static application, mats, foot pads, things like that. But it's starting to be looked at some of the higher, more dynamic or applications like the conveyor belting. We've seen some people looking at hose and have some success already. Going into factory trials, and of course any kind of roofing or flashing, those kind of things. It's very dependent on the application put in and the integration you can get into the formulation. Obviously the CLMS materials are going to be more compatible because they're a closed loop process, so using the exact same material, and actually some of those we've seen almost no change whatsoever in properties with the integration of 10 to 20%, which is fantastic. And then right now we have quite a few people looking at various applications across the board. So I think we're going to see a lot more success as we move forward.
The question is, what polymer groups work well with your technology? Ted?
You know, it's funny because I have a delay, so I don't see the actual question for like 20 seconds after you read it. That's why I'm sitting here like, what? Polymer groups, obviously natural rubber, SBR, those are going to be the most effective with the TDPs. The CLMS, whatever the polymer is, it's going to work. Obviously it's a closed loop, so they're going to put it in the same kind of things. We've looked at EPDMs, and we've looked at SBRs, and we've looked at natural rubbers, and I think those are the ones we looked at so far. For the TDP, I've actually been able to integrate a certain amount into EPDM and chloroprene. And it's 10 to 15%, but it's still a nice increase in a recycled content of a material. We've also started looking at nitrile. Essentially anything with a sulfur cure, it should work. Anything. Because of the process, there shouldn't be any issues. And then integration just depends on the type of compound, the properties, and how creative you get.
So Ted, this question is, what is the devulcanization process like, and can you explain a little bit more? I know you covered this earlier.
Yeah, like I said, it's the thermomechanical process. Essentially, you're looking at a twin screw, and you're going to run the material in a ground form, crumb form, into the extruder at a certain feed rate, and you're going to have a certain screw rate to generate the right kind of shear curve that you want to get. We introduced the supercritical carbon dioxide at very, very low level just to help. It helps the rubber swell just a little bit to encourage the breaking of the sulfur bonds. So it's really a closed system. There's very little loss. There's a vent for any kind of gases that might come off, but there's very, very little generation of that. And then when it comes out the other side of the extruder, You can put in any form you want, but it's just like an extruder. But we tend to put into a just a slab of rubber, and that can be cut to size for handling. So it's very straightforward process. There's a lot of I don't want to make it sound so easy. There is a lot of how do I want to put this? A lot of work and study and technology in the setups, the feed rates, the temperatures, the screw speeds, the timing of introduction of carbon dioxide. There's a lot that's background in there, but it's actually a very simple process when you look at it from the big picture.
So Ted, can you comment about the dynamic properties, rolling resistance and traction impacted by use of TDP? So this must be coming from a tire industry participant.
I don't have a lot of information on this, to be honest with you. A lot of the retread work, rolling resistance is a very important thing. Much because a lot of the OTR stuff is off-road and they're not going very fast. Traction, if you look at some of the basics with regards to dynamic properties of dynamic modules and loss modules, you don't see a giant difference. You maintain the very similar modulus and durometer properties. Wear is equivalent. Matter of fact, I've seen almost no change in the abrasion testing I did on conveyors. So in a tire, I'd expect the same kind of thing. But I really don't have a lot of information on the actual dynamic properties. I have not personally done that specific testing on this material at this point.
Next question.
It's a good question.
Yeah, excellent question. And I would encourage that that participant to engage with us so we can work one-on-one with them.
Well, I've been
what percentage integrations should we expect or can we achieve?
Well, again, that's all over the board, but I usually start with the 20% when I start working with a compound. To date, I've gone anywhere from 10% to 45%, depending on the application. The 10% was more related to a TDP in a different polymer, like an EPDM or a chloroprene. Certainly, the SBRs, naturals, BRs, it's been 20% or more. So I think you can expect easily that level. If it's a CLMS, I think there's probably opportunity for even more.
Yeah, and as we mentioned earlier, we're working with one customer that's actually in the vehicle flooring industry that's utilizing our TDP as a 100% integration material. Ted, can you comment a little bit about the quality standards of TDPB and TDPC?
Yeah, essentially we have standards for the type of material that comes in, cleanliness, of course, but also we do testing just to make sure that they meet within a certain requirements of polymer content and filler and ash, much like a lot of these type of things in the past. And then what we do is they have a once it's devulcanized, there's a standard formulation that we mix in the lab to verify that material is meeting certain properties. It's a very simple formulation where you just mix a certain cure system into the devulcanized material, and we expect certain properties to come out. We measure viscosity, tensile, and elongation, physical properties. And then we have a measurement of the viscosity of the TDP itself, even before we blend the recipe. So it's like any other material where you pick the certain properties that you're going to measure to verify that the process is still in control. Because really, when it comes down to it, this type of material, the process has to be in control to make sure it's consistent. So, and we see extreme consistency on TDP B and C. And as we're moving forward, it's each new material, like the CLMS and all that, we have to do some work to set up the process to get to the place that the customer wants. And once it's set up, then we set those standards. This is the viscosity, this is the properties from the lab verification batch. Okay, is this a drop-in material or other adjustments needing to be made? It's not really just a drop-in material. You don't want to just treat it like like a ground rubber or something like that, where you're just going to throw in to dilute the formulation. You have to look at the formulation, and you have to say, okay, I'm going to add this material. It's like a master batch. I know that it's going to have somewhere around 50% polymer, and the rest is going to be carbon black and some other smaller ingredients. And what you want to do is you want to adjust your formulation based on that, and try to optimize what properties you're going to get, especially if you're trying to maintain a certain hardness or modulus profile. There is a second way you can do it, and that is adding it as a master batch. And we've done this in certain formulations where the properties are very similar to what the TDP offer. So if the TDP offers like a 1800, 2000 PSI tensile and a 65 durometer, then if I have a formulation that's very similar to that, I can just add this as a master batch, which just kind of dilutes the whole compound, but then I add a little bit of Cure extra accelerator to account for that portion of the master batch. So it's kind of open to what's going to work best for your material and your process.
Yeah, and to add to Ted's comments there, our most successful projects are where we basically work side by side with our customer, where they attempt to integrate the material and then share with us the results of that integration, so that we can provide guidance on how to best do a second version of that, or what other adjustments to make to get closer to their desired properties. So this question, Ted, is regarding, is this a polymer replacement or a master batch replacement or a filler replacement?
Well, it kind of goes along with the last question. It's really you're looking at the polymer. You've basically taken and devulcanized the material so that you have usable polymer again. So it's not a filler replacement. You don't want to look at it that way. So you want to compound with it based on the anticipation that it's going to participate in the matrix, in the polymer matrix, in the cross-linking. And yes, from a standpoint of there are other components in there. There's a filler and all that from the material you devulcanize, but the focus is more on the polymer. You can adjust the filler level depending on where you are with your durometer, and what modules profile you're trying to create. You might adjust the filler a little up or down depending on where you are with your durometer, but essentially it is looking at the polymer.
Right. Thank you, Ted.
Hey,
Good,
ARDL.
ARDL. Yep, go ahead.
I actually got this
read
one.
it.
ARDL,
Yep.
there's research going on latex industry waste. I have not been involved in any of the latex industry waste. I am not sure of research going on at this moment. I'll have to look into that because that's obviously that's a big industry. We do a lot of testing on gloves in ARDL, so I'll have to look into that one. Whoever asked about that, if they want to contact me, I can dig into that a little bit more.
Okay, thank you, Ted, and thank you, Hugo, for the addressing all the points that audience raised. It's time to end this session. Before I end the session, may I ask you to give your final remarks to the audience? May I ask Ted to go first?
Yeah, I've been looking at recycled materials. Pretty much anybody who came in with anything that was recycled or new since 2002, I would look at it. I was in custom mix at the time, and I always saw the opportunity as an advantage over other people. I've had capabilities of producing commercial products with up to 20-25% recycled materials in the past, where they were actually commercial products that I was selling into the industry. I have never, of all the devulcanized technology I've looked at, this is the first devulcanized technology that actually have produced a viable material that you can compound with. All the other ones I've looked at, there was some problem. It had no guts left to it. It just really poorly, no mechanical strength or too much moisture content. So you couldn't actually produce a good product consistently on them. Other times there just wasn't enough devulcanization. So basically for the value wasn't there. So this technology is one of the, it's the first devulcanization technology that I've actually, I think has a very good future, and I think there's a lot of people who can benefit from it. Thank you.
Ted, let's go, Hugo.
Yeah, and to echo Ted's comments, in my 15 years at Hexpol Compounding and predecessor companies, we looked at many different iterations of devulcanization and other like technologies. And when I came across North Shore Rubber and understood their technology a little bit better, I got really excited because I believe that this is the real deal. And I've talked to some very high-level experts in the industry, and they've given me the nods up, the thumbs up that this is the real deal. And I'm very excited as we build out North Shore Rubber and work with our technology partner to make this happen. And I would encourage any of the participants or listeners to this broadcast to engage with us. Check us out. We'd love to partner up with you and find out how we can help you achieve increased sustainability, reduce your carbon footprint, and save money in the process. So, and I want to thank Param and the TechnoBiz team for allowing us to participate in the Rubber News Hour.
Yes, thank you.
Thank you, Ted. Thank you, Hugo. It's a very interesting and useful presentation on the on this important subject. I think everybody's talking about it. Every tire industry, every non-tire industry is also talking about the recycled material. So Thanks a lot, guys. So that's the end of the session today. I'm hoping that you find this session useful. If you have any further questions on this, please do write to Hugo. He has given you the email address in his handout. Feel free to download it, or you can always write to me. Thanks once again, Hugo and Ted, for being part of the Rubber Industry News. So I appreciate the participation, guys.
Thank you.
Thank you.
I see. So I look forward to seeing you all in the next episode. Thank you for joining this session today. Bye-bye for now.
Okay, bye.
Bye-bye.